All right, diving in today. And suction pumps. They're everywhere, right?
Oh, absolutely. You find them in so many applications. Buildings, industrial processes, you name it.
And you brought this super detailed guide on troubleshooting them. So we're going to extract the gems, make it useful whether you're, a pump whisperer or just starting out.
Yeah. The thing is, these pumps are usually pretty reliable, but when they do have issues, it can be a real pain.
Right, like throws everything off.
Exactly.
So before we even get to troubleshooting, remind me of the key parts we got to understand. What are we dealing with here?
Okay, so the core, the heart of it, is the impeller.
Okay.
That's what's actually moving the fluid. It's this spinning component, and it's driven by a shaft. And that shaft is supported by bearings. And all of that is housed within the volute casing, which is kind of like the shell that directs the flow. And then you've got the mechanical seal, which is super important.
To prevent leaks, right?
Exactly, yeah. You don't want leaks. And of course, you have the nozzles, which are where the fluid enters and exits. It's all got to work together.
Yeah, like a well-oiled machine.
Exactly.
So what's the first pump problem that people typically, run into? What's the thing that throws them off?
One of the most common complaints is just not enough flow.
Oh, really?
The pump's just not delivering. Like, it should be moving this much, and it's only moving this much.
Not doing its job.
Right. And there are a few usual suspects. Air in the suction line, that's a big one.
What does that mean, air in the suction line?
Okay, imagine you're trying to, drink a milkshake through a straw, but the straw has a hole in it.
Oh, yeah.
So you're working hard, but not getting a lot of milkshake.
That makes sense, yeah.
Same with the pump. If there's air in there, it can't create that vacuum to pull the fluid.
Gotcha. So besides a holey straw, what else?
A clogged impeller. So over time, debris, gunk, whatever, can build up and obstruct the flow.
So like a vacuum cleaner with a full bag?
Exactly.
Yeah.
And then, believe it or not, sometimes the pump's running in reverse.
Running backwards.
Yeah, so it's not moving any fluid in the right direction at all.
So it's not always a complex fix. It could be something simple like that. What about more technical issues that can affect flow?
So there's something called net positive suction head, or NPSH.
Okay.
And in simple terms, it's basically the pressure available at the pump's suction side.
Okay.
So if that pressure's too low, the pump can't draw in enough fluid.
I see.
And that leads to reduced flow.
Yeah.
One trick is to shorten the suction pipe.
Shorten the pipe. Okay.
That can sometimes help improve the NPSH.
So it's like enough oomph to get it going.
Yeah.
Okay, cool. And then I guess over time, wear and tear?
Absolutely. Worn wear rings, a damaged impeller, that can all impact how well the pump's flowing.
Yeah, it's like anything. Things get tired, need a little attention.
Exactly.
Okay, so low flow, that's one problem. What about when a pump's just using a ton of energy?
Yes. That's nobody's friend, right?
No. Yeah.
And oftentimes, that comes down to it operating far from its best efficiency point.
Okay, BEP.
Yeah. So imagine a graph of pump efficiency. The BEP is the peak. That's where it's running most smoothly, using the least amount of energy.
Okay, so we want to be at that sweet spot.
Exactly. But lots of things can knock it off that sweet spot.
Misalignment's a common one.
Misalignment, what does that mean?
If the pump and motor shafts aren't perfectly aligned, it's like a wonky wheel on a bike.
Oh, yeah, it creates friction.
Exactly. Wastes energy. Same with worn bearings.
Okay.
Excess friction, more energy wasted. And sometimes it's the fluid itself.
Oh, right, what you're pumping.
Yeah, thicker fluids take more energy to move. Think of it like stirring water versus stirring honey.
Yeah, that makes sense. Honey's a workout.
Right.
All right,
Yeah.
so low flow energy hogs.
Mm-hmm.
What's next on our list of pump woes?
All right, let's talk about noise and vibration.
Oh, yeah.
Because a noisy pump can be a real indicator that something's not right. And these vibrations can be so bad you'd think it was going to, walk away.
I've seen that. Yeah.
It's scary.
It is. So one of the culprits there is cavitation.
Cavitation.
Yeah, and this one's kind of dramatic. So imagine tiny bubbles forming in the fluid because of pressure changes.
Okay.
And then those bubbles implode. And when they implode, they create shock waves.
Oh, wow.
And those shock waves damage the pump. They make noise. It's like this constant popcorn popping symphony inside.
Ouch. That can't be good. So how do we stop the popcorn party?
That NPSH we talked about earlier,
Right.
making sure that's adequate can help prevent cavitation. Also, no air in the suction line. That's key too.
So NPSH officially on my watch list now. Okay. Other things that cause vibrations.
Bearing failure.
Yeah.
That's another common one. Worn or damaged bearings, they'll create all sorts of racket.
Right.
And then misalignment,
Misalignment.
that comes up a lot.
It's like the root of all evil.
It really can be. Loose mounting can also be an issue
Okay.
if the pump's not securely anchored.
Yeah.
like a wobbly table leg.
Right, yeah. It's all about the foundation.
Yeah.
Okay, so loose mounting. What else?
An unbalanced impeller can cause problems, like an off-balance washing machine.
Ah, yeah. During the spin cycle. Makes the whole thing shake.
Exactly. And then there's this thing called
A
resonance.
resonance. That sounds a little more complex.
It is a bit.
Hmm.
Okay, so think of this. You have two tuning forks. They vibrate at the same frequency,
Okay.
and you strike one. The other one will start to vibrate too, even though you didn't touch it.
Interesting.
That's resonance.
So how does that apply to pumps?
So in a pump system, you can have resonance if the pump's operating frequency happens to match the natural frequency of, say, the piping.
Oh, okay.
And then it amplifies the vibrations, leading to more noise, potential damage. It's like they're feeding off each other's energy.
Okay. So how do you deal with a pump that's got resonance?
Sometimes a simple speed adjustment can shift it away from that resonant frequency,
Oh, okay.
but sometimes you need more involved solutions like vibration dampeners or even modifications to the piping.
Gotcha. All right, so resonance, another thing for the checklist. Okay, let's move on to leaky seals,
Ah, yes.
which can be, annoying and also hazardous.
Absolutely. Waste of resources, environmental concerns, even safety hazards.
Yeah.
And the reasons why a seal might fail, it's kind of surprising how many there are.
Yeah, like what are the common ones?
You'd be surprised how often it's improper installation. Even experienced technicians, we all make mistakes. So following the manufacturer's instructions is key. And then misalignment.
Misalignment, shocker.
It's the gift that keeps on giving,
Yeah.
but then running a pump dry.
Oh, yeah.
That's a big no-no. It's like running your car engine without oil.
Yeah, not good.
Not going to end well. And then you have to consider the chemical compatibility.
Oh, right,
Well,
between the seal and the fluid.
exactly. Like if you've got a corrosive fluid, it can eat away at the seal.
Like using the wrong cleaning product on a surface and it ruins it.
Yeah, exactly. And temperature's a big one too.
Oh, right, heat.
Yeah, excessive heat, you can push seals past their limits.
So it's all about staying cool under pressure.
Literally, yeah.
Literally. All right, any other sneaky causes of leaks we should watch out for?
One that's often overlooked is a dirty seal chamber.
Okay.
If dirt or debris gets in there, it can interfere with the seal, and eventually you've got a leak.
So keeping things clean is important.
Very important.
So when you're faced with a leaky seal, what's the best way to tackle that?
Well, first you got to figure out why it's leaking.
Right.
Once you know the culprit, then you can fix it the right way.
So it's a bit of detective work,
It can be.
but worth it to avoid the leaks. Okay, let's talk about preventative maintenance. This is all about making our life easier.
It really is. Think of it like a spa day for your pump. Just regular care so you can avoid those major meltdowns.
I like that, pump spa day. So what does a good preventative maintenance plan, what does that involve?
Well, it starts with regular inspections. Daily, weekly, monthly, quarterly, and annual checkups.
So we're checking in on them regularly, but what are we actually looking for during these inspections?
You want to keep an eye on the key parameters. Pressure, flow rate, power consumption, temperature, vibration, seal chamber pressure.
Okay, so it's like taking its vital signs.
Exactly. And, just like a good doctor keeps good records, you'll want to document all of this. Think of it as your pump's health journal. You can see how it's performing over time and spot trends.
So we're inspecting, we're monitoring, we're documenting. What's the big payoff for all this diligence?
Well, preventative maintenance, it's all about catching those small issues before they become big problems. Saves you time, money, stress in the long run. A well-maintained pump is a happy pump.
I love that. Okay, let's talk about some of the cool tech that can help us troubleshoot those trickier problems. This is the fun stuff.
Oh, yeah. I love this part. We're talking tools that take the guesswork out of troubleshooting.
Okay, give us the highlights. What are we talking about?
So first up, vibration analyzers.
Right.
These are like stethoscopes for pumps. We can listen to those internal vibrations.
So we can actually hear what's going on inside.
In a way, yeah. They measure the frequency and amplitude of vibrations, which tell us a lot about the pump's condition. Different problems create different vibration patterns, so a worn bearing is going to sound different than, say, an unbalanced impeller.
That's so cool. So we're decoding the secret language of vibrations.
Exactly. And then we have thermal imaging cameras. These can detect hotspots that might indicate a problem, like bearing problems, lubrication issues, stuff like that.
So giving our pumps an infrared checkup.
Exactly. And then there are ultrasonic detectors. Fantastic for finding leaks,
Yeah.
especially those tiny ones you can't see or hear. They use sound waves to detect leaks.
So sound waves to hunt down those leaks. Very cool. What else?
Power quality analyzers.
Oh.
These are key for tracking energy use. Help you identify those pumps that are guzzling too much power.
So we can catch those energy hogs. All right, what else do we have in our arsenal?
Last but not least, laser alignment tools. These are the champions of precision. They use lasers to make sure the pump and motor shafts are perfectly aligned.
Right. Alignment is key. We've learned that. Okay, so we've got our high-tech toolkit ready to go. But before we start tinkering, let's talk about safety.
Absolutely.
Always got to be top of mind.
Couldn't agree more. We're dealing with powerful machines, sometimes hazardous fluids, so let's go over some safety precautions.
Okay, safety first. What are the golden rules?
Lockout, tag-out procedures. Those are non-negotiables.
Lock out, tag out.
You have to make absolutely sure that the pump is de-energized and can't be started accidentally while you're working on it.
No accidental starts. Got it.
What else? Personal protective equipment. PPE. Gloves, safety glasses, hearing protection, whatever's needed for the task at hand.
Safety gear, check. What about situations where there's hot work involved, like welding?
Permits. You have to have permits for hot work. That way, everyone's on the same page and the right precautions are in place.
Okay, permits for hot work. Anything else?
Confined spaces. If you're working in a confined space like a pump pit, there are very specific procedures you need to follow.
Got it. Confined space procedures. Any last safety tips?
If you're dealing with hazardous fluids, proper chemical handling is a must. You need to know how to handle them, store them, dispose of them safely.
Right, we want to avoid any spills or exposure. So we talked about lockout, tag out, PPE, hot work permits, confined space procedures, chemical handling. Anything else we should be prepared for?
It's always a good idea to have emergency plans in place.
Okay.
So knowing the shutdown procedures for the pump, having spill containment measures ready, knowing basic first aid, having emergency contacts handy.
Great advice. Always be prepared. Now let's talk about keeping costs down. Maintaining these pumps, it can get expensive. So what are some tips for being cost effective?
One of the smartest things you can do is manage your inventory effectively. Have a list of critical spare parts and keep them on hand.
So we're creating a strategic spare parts stockpile.
Exactly. That way you're not scrambling when something breaks.
Good point. What else can we do to keep costs down?
Building good relationships with your vendors.
Oh, yeah.
They can be valuable partners.
Having a pump expert on speed dial.
Exactly. Also, proper storage of your spare parts. You don't want them rusting away in a corner somewhere. Keep them clean, dry, organized.
Okay, so we're treating those spare parts like the valuable assets they are.
Exactly.
What else?
Know your reorder points for each part. Don't wait till the last minute. Running out of a critical part can lead to downtime, which costs money.
Yeah, order early, avoid the scramble.
Exactly. And keep track of your maintenance costs. That way you can identify areas where you might be overspending.
Okay, track expenses, look for ways to be more efficient. Anything else?
Invest in your team's training.
Oh yeah, that's a good one.
A well-trained team is less likely to make mistakes. They can troubleshoot better, which reduces downtime.
Absolutely. Empowering your team with knowledge and skills is a great investment. Well, we've covered a lot of ground today. Explored the inner workings of end suction pumps, common problems, how to troubleshoot them. We talked about preventative maintenance.
Yeah, all those regular checkups that can save you headaches down the line.
We even talked about some of the cool tech tools that can make troubleshooting easier.
Those are always fun.
But through it all, we've emphasized that safety should always be top priority.
Of course, lockout, tag out, PPE, permits, proper procedures, that's all crucial.
Absolutely. And we wrapped things up with some practical tips for keeping those maintenance costs in check.
Smart inventory, good relationships, proper storage, tracking your costs, and investing in your team. That's a recipe for a healthier pump and a healthier bottom line.
Absolutely. So what does all of this mean for you? You came to us with this guide because you wanted to understand these pumps better. What are some key takeaways you can apply?
Well, you're now armed with the knowledge to tackle those end suction pump challenges. You can diagnose problems, find solutions, take steps to prevent issues, and keep your pumps running smoothly.
It's like you've leveled up your pump expertise.
Exactly. And remember, this is just the beginning. There's always more to learn in the world of pumps.
Keep that curiosity going. If this deep dive sparked your interest, there are tons of resources out there. Thanks for joining us on this deep dive into end suction pumps. We'll catch you next time for another adventure in knowledge.
And then there's the chemical compatibility between the seal material and the fluid you're pumping.
Right, like you got to make sure it can handle it.
Exactly. So like if you've got a corrosive fluid, it can eat away at the seal.
Like using the wrong cleaning product on a surface.
Yeah, exactly. And temperature. Temperature's another big one.
Oh, yeah. Heat.
Excessive heat. It can really push seals past their limits.
So staying cool under pressure, literally.
Literally, yes. And then one that often gets overlooked, a dirty seal chamber. If dirt and debris get in there, it can interfere with the seal and eventually leak.
So keeping things clean.
Very important.
Very important.
Yeah.
Okay, so when you're faced with a leaky seal, what's the best way to approach that?
Well, first you got to figure out why it's leaking.
Right.
What's the root cause? Once you know that, then you can take the right steps to fix it.
So it's a bit of detective work.
A little bit, yeah.
But worth it to avoid those leaks. Okay, let's talk about preventative maintenance. This is all about, like, making our lives easier, right?
Exactly. It's like, think of it like a spa day for your pump.
Okay.
Just regular care to help it avoid those major meltdowns.
I like that. Pump spa day.
Yeah.
So what does a good preventative maintenance plan actually involve?
Well, it starts with regular inspections, daily, weekly, monthly, quarterly, annually, depending on the pump and how much it's used.
So checking in on them regularly, but what are we actually looking at during those inspections?
So you want to keep an eye on those key parameters.
Yeah.
Pressure, flow rate, power consumption, temperature, vibration, seal chamber pressure.
Okay, so we're taking its vital signs.
Exactly. And just like a good doctor keeps meticulous records, you'll want to document all this stuff. Think of it as your pump's health journal.
Okay.
You can see how it's performing over time, spot trends,
So we're inspecting, we're monitoring, we're documenting. What's the benefit? What's the payoff for all this?
Well, preventative maintenance is all about catching those small issues before they become big problems. Save yourself some time, money, stress down the line. A well-maintained pump is a happy pump.
I love that. Okay, let's talk about some of the cool tech that can help with troubleshooting. This is the fun stuff.
Oh, yeah. This is where I get to geek out a little bit.
Right. We're talking about tools that can, like, take the guesswork out of it.
Exactly. So first up, vibration analyzers.
Oh, okay.
These are like stethoscopes for pumps.
Oh, cool.
We can actually listen to the internal vibrations.
So we can actually hear what's happening inside.
In a way, yeah. They measure the frequency and amplitude of the vibrations, which can tell us a lot about the pump's condition. Different problems will create different vibration patterns. So, like, a worn bearing is going to have a different vibration signature than, say, an unbalanced impeller.
That's fascinating. So we're decoding the secret language of vibrations.
Exactly. And then we have thermal imaging cameras.
Okay.
These are great for detecting hot spots.
Yeah.
That could indicate a problem like bearing issues, lubrication problems, things like that.
So, like, giving the pump an infrared checkup.
Exactly. Then there are ultrasonic detectors.
Okay.
Fantastic for finding leaks, especially those tiny ones that you can't see or hear. They use sound waves to find those leaks.
Sound waves to hunt down leaks. Very cool. What else do we have?
Power quality analyzers. These are essential for tracking energy use. So you can identify those pumps that are just using way too much power.
Catch those energy hogs red-handed.
Exactly. And then last but not least, laser alignment tools. These are the champions of precision. Make sure those pump and motor shafts are perfectly aligned.
Yeah. Alignment is key. We've learned that.
It really is.
Okay, so we've got our high-tech toolkit, but before we start, tinkering, we got to talk about safety.
Absolutely. Can't emphasize that enough.
Always has to be top of mind, right?
Yeah. We're working with powerful machines, sometimes hazardous fluids. So let's go over some key precautions.
Safety first.
Yeah.
What are the golden rules?
Lockout, tag-out procedures. Those are non-negotiable.
Lockout, tag out.
You got to make absolutely sure the pump is de-energized. Can't be accidentally started while you're working on it.
No accidental starts. Got it. What else?
Personal protective equipment, your PPE, gloves, safety glasses, hearing protection, whatever you need for the task.
Safety gear, check. What about situations where there's hot work involved, like welding?
Permits. You got to have permits for any hot work. Make sure everyone's on the same page and the right precautions are in place.
Permits for hot work. Okay. Anything else?
Confined spaces. If you're working in a confined space, like a pump pit, there are specific procedures to follow.
Got it. Confined space procedures.
Yeah.
Any other safety tips?
If you're dealing with hazardous fluids, proper chemical handling is absolutely critical. You need to know how to handle them, store them, dispose of them safely.
Right. No spills, no exposures. Okay, so we talked about lockout, tagout, PPZ, hot work permits, confined space procedures, chemical handling. Anything else we need to be prepared for?
It's always wise to have emergency plans in place.
Right.
Know the shutdown procedures for the pump, have spill containment measures ready, know basic first aid. Have those emergency contacts handy.
That's great advice. Always be prepared. Now let's talk about keeping costs down. Maintaining pumps, it can get expensive. So any tips for being cost effective?
Well, one of the smartest things is to manage your inventory effectively. Have a list of critical spare parts and keep them on hand.
So we're creating a spare parts stockpile.
Exactly, so you're not caught off guard when something breaks.
Okay, good point. What else?
Build good relationships with your vendors.
Oh, yeah.
They can be really valuable partners.
Having a pump expert on speed dial.
Exactly. And proper storage of your spare parts. You don't want them, rusting away in a corner. Keep them clean, dry, organized.
So we're treating those spare parts like the valuable assets they are.
Exactly.
What else can we do?
Know your reorder points for each part. Don't wait till the last minute to order stuff. Running out of a critical part, that can lead to downtime, which costs money.
Right. Order early. Avoid the the last minute panic.
Exactly. And keep track of your maintenance costs. Really look at where you're spending money so you can identify areas where you might be overspending.
Track those expenses, find ways to be more efficient. Anything else?
Invest in your team's training.
Oh, yeah. That's a good one.
A well-trained team is less likely to make mistakes. They can troubleshoot better, which reduces downtime.
Totally agree. Empowering your team with knowledge and skills, that's a smart investment. Well, we've covered a lot of ground today. We explored the inner workings of end suction pumps, dove into some common problems, learned how to troubleshoot. We talked about preventive maintenance, all those regular checkups that can save you headaches down the road. We even got to talk about some of the cool tech tools that can make troubleshooting easier and more efficient. But through it all, we've emphasized that safety should always be the top priority when working with pumps. Lockout, tagout, personal protective equipment, permits, the right procedures, all crucial. And we wrap things up with some practical tips for keeping those maintenance costs under control. Smart inventory management, strong vendor relationships, proper storage, tracking your costs, investing in your team's training, all great strategies for a healthier pump and a healthier bottom line. So what does all of this mean for you? You came to us with this guide because you wanted to understand these pumps better. What are some key takeaways you can apply?
Well, now you're armed with the knowledge to tackle those end suction pump challenges head on. You can diagnose problems, you can implement solutions, you can take steps to prevent future issues, and you can keep your pumps running smoothly and efficiently.
It's like you've leveled up your pump expertise.
Exactly. And remember, this is just the beginning. The world of pumps is vast. There's always more to learn.
So keep that curiosity going. If this deep dive sparked your interest, there are tons of resources out there to explore. Thanks for joining us on this deep dive into end suction pumps. We'll catch you next time for another adventure in knowledge. We talked about preventative maintenance, all those regular checkups and tune-ups, the stuff that keeps things running smoothly.
And we even explored some of the cool tech tools that can help pinpoint problems and, make troubleshooting a little less of a headache.
But safety first, right? You've
fine.
got to emphasize that.
Absolutely. Always. Lockout, tagout procedures, PPE, permits, the right procedures. It all matters.
Couldn't agree more. And then, we wrap things up with some tips for keeping those maintenance costs under control.
Yeah, being strategic about your inventory, having good relationships with your vendors, storing your spare parts properly, tracking those costs, and, investing in your team's training.
It all adds up, right? A healthier pump and a healthier bottom line.
Exactly. So thinking back to why you brought this guide to us, you wanted to understand these pumps better. What are some of the big things you're taking away? What can you actually apply?
Yeah, what are you walking away with?
Well, I think you're walking away with the knowledge to tackle those end suction pump challenges head on. You can diagnose problems, find solutions, and take steps to prevent those issues from popping up again.
Yeah.
And ultimately, keep those pumps humming along.
You've leveled up your pump game for sure.
Exactly. And remember, this is just the start, right? There's always more to learn about pumps.
Always more to explore, so keep that curiosity going. If this deep dive sparked your interest, there are tons of resources out there, so dive in. Thanks for joining us on this deep dive into end suction pumps. We'll catch you next time for another adventure in knowledge.